So now we're going to talk about conjugates. Well, what are conjugates? And we're using this in the sense of with radicals, okay? Square roots. So let's say you have the square root of A plus the square root of B. Now, you can't add those together because the radicals aren't the same. The square roots aren't the same. So it's an expression. And you could have something like that. A and B are representing real numbers. The conjugate would be, it's the same thing, square root of A, only minus the square root of B. Those are considered conjugates. So they're not opposites because they're not both negative, right? Okay, so you're just changing the addition sign to a subtraction sign. And so that's what we mean by conjugate. Now you could say, well, what if I had the subtraction sign, then you'd change it to an addition sign. Okay, so let's see what happens when we take conjugates, so the square root of A plus the square root of B, and we multiply them together. When we talk about conjugates, kind of come in pairs. So here's one expression, square root of A plus the square root of B, and here's the conjugate of that expression, square root of A minus the square root of B. Well, when we multiply, you have the square root of A times the square root of A, right? That's the square root of A squared, right? Because they're the same. Then you have the square root of A times the square root of B. But notice that this is positive and this is negative. So it would be negative square root A square root B. Then, and I'm using, to multiply these, I'm using FOIL, but think of it as like double distributing. You could do it that way too. I'm just saving a little time here. Now if I multiply these two together, I get the square root of A times the square root of B. And then if I multiply these two together, I'd have minus the square root of B squared. Now let's just assume that, well, we don't have to assume anything. This is going to work because we've got the square on the outside, right? So that's just going to simplify to be A. And then what's going to simplify here is you're going to have the square root of AB. You could write it that way. And then you're going to have plus the square root of AB. But notice that this one is got a minus sign in front of it. This has an addition sign. Oops. Oh, no, that's right. Sorry. And then at the end here, we're going to have minus. That's the sign right there. And that's going to be B. Well, these little squiggly lines I have here, those two terms are going to cancel out. Those add up to 0. So I get just A minus B. And notice that there's no radicals anymore. Okay, that's the beauty of the conjugates. They're able to simplify things for us sometimes. So when we're working with these square roots, we can use the concept of conjugates to get rid of the square root sign. So we're going to use that to rationalize the denominator. Now, why isn't this the same as the problem we did before? Like, why do I have to learn about conjugates? Why can't I just multiply by the square root of 3? Well, you'd run into a problem if you were to multiply that by just the square root of 3. This part would be okay. That'd be the square root of 9, which would be 3. But then the radical would pop up over here. You'd have 5 times the square root of 3 plus the square root of 9. This would be 3, but then I'd still have the radical, so I'd be back to having a problem. So that doesn't help. Okay. So because there are two terms, like how are you going to know? Well, I have two terms, right? I have addition or subtraction down there, and there's also a radical or a square root sign. That's how you're going to know to use the conjugate. Okay? So let me make this just a little bit bigger. And we're going to multiply by the conjugate of the denominator. So it's 5 plus the square root of 3. So we're going to multiply by 5 minus the square root of 3. Now, whatever we multiply by in the denominator, we have to multiply in the numerator. So remember, we're trying to rationalize the denominator. Look down for the denominator, okay? Otherwise, you're going to run into trouble. Okay, so now what happens? Well, in the numerator, I have 7 times 5 minus the square root of 3. Now, you might say, well, why didn't you distribute the 7? I could have. I decided not to. I'm going to wait and see what happens in the denominator, because maybe I'll be able to simplify. Okay, Now, there's two ways you can do this. You can do it quickly, or you can, take and multiply everything out. But we know it's going to be 5 times 5, so it's going to be that part, which is 25. And then the outside part is minus 5 times the square root of 3. The inside part is plus 5 times the square root of 3. Those are going to cancel out every time. So it doesn't matter if you multiply them out. You can just ignore them if you want. But then you're going to have minus the square root of 9. Because you've got, let me do it in orange, that part there. So 3 times 3 is 9. Or you could just put 3. That would work as well. So you're going to have 25 minus 3, which is 22. Okay, I would probably leave it that way. Now, I talked about why didn't I distribute the 7? Well, because maybe this turned out to be a 21, and then the 7 would cancel into the 21. So that's why I didn't. But they can distribute, so I would probably leave my answer like this. But they very well could have the answer with the distributing, and it would look like this. Okay? So either answer is fine with me. Just so that you know, this is a real number. It's not got any variables in it. You can put that in a calculator and get a decimal approximation. It's not a rational number, but it is real. Okay?